वेलकम स्टूडेंट टू द न्यू सेशन। तो चलिए स्टार्ट करते हैं विदाउट वेस्टिंग मच टाइम। तो लास्ट बार हमने द प्रॉपर्टी नंबर 4-5 का अच्छा एप्लीकेशन देखा था इन दिस क्वेश्चन। हियर आल्सो वी आर गोइंग टू कंटिन्यू विद दिस। देखो भाई, यहाँ पर एक बड़ा सा आपको एक अच्छा एक्सप्रेशन दिया हुआ है log of 1 by x minus 1, जिसको आपको इंटीग्रेट करना है 0 to 1। इट्स वेरी इजी। पहले तो मैं इसका एलसीएम ले लूंगा, इट बिकम log of 1 minus x over x। जैसे मैं इसको एलसीएम लूंगा, आई नो आई कैन राइट इट एज log of 1 minus x and minus log x as per the property of log of a divided by b is equal to log of a minus log b। ठीक है भाई, इसके बाद मैं क्या बोलूंगा कि जब मैं इसमें इंटीग्रेशन इस पे और इस पे लगाता हूँ, द फर्स्ट एक्सप्रेशन आई वांट टू होल्ड एज इट इज, कि मैंने इसको 0 से 1 लिखा। सेकंड एक्सप्रेशन में जैसे ही प्रॉपर्टी नंबर 4 को अप्लाई करता हूँ, इट गॉट कन्वर्टेड टू log of 1 minus x and the limit remains same, that is 0 to 1। they will cancel out and I will got my answer as 0। Fine, so this question is very easy for you। Now let's come, and this is a pre-written explanation also, where you can see I have shown you all this thing. You can use this formula and obviously you can see it's a very easy, you can refer this। Now let's come to the illustration number 7। now here also if you see, you can easily apply the property number 4। you can see in your denominator there is sin x and cos x, which change interchangeably, like sin to cos, cos to sin। so if you try to do like that, it will become a cos x। okay, I have applied the property directly, that is I'm putting x in place of x, I'm putting pi by 2 minus x, because a plus b is pi by 2। so I got a cos x plus b sin x in my this numerator, and denominator I got sin x plus cos x। fine, a little bit of steps you need to cancel in your mind for the better and the faster solution। okay, now let's come to this thing again। see, if you try to add, if I call this as equation 1 and equation 2, both are actually your integral I, which you want to find। on the right hand side, sorry, on the left hand side first, you will get what? On the left hand side you will get 2i, and on the right hand side what will be there? You will be having the integration 0 to pi by 2, your denominator you already know, that is sin x plus cos x, and your numerator become what? Now try to analyze here. Here we have a sin x, here we have a cos x, here we have b cos x, here we have b sin x। so when we take a and b common from what inside in the brackets, I'll be having uh, okay, in, just let me do this, yes, in the inside the bracket I'll be having sin x plus cos x, and a outside, and here also the same thing, b sin x plus cos x। now what you will do, you will take sin x plus cos x common, and you can see the denominator is also sin x plus cos x, so that will cancel out and you will get only a plus b over here, and that's 0 to pi by 2। so you will get a plus b x, and in x when you put the upper limit and lower limit, that is upper limit minus lower limit you will doing, so you get pi by 2 minus 0। and on the right hand side, on the left hand side you have I 2i, so that goes here, so you will get a plus b pi by 4। fine, so that is all about this question। now you can see, refer the pre-written solution, the same thing they have done, they converted into the this is your original expression, I can say, they converted into this, they add 1 and 2, basically they are calling it as equation 2, and they are calling it as the original expression as equation 1, and then when they are adding, you are getting this one। fine, now let's come to the illustration number 8। here you have to show that 0 to pi by 2 sin square x sin plus cos x, okay, all this thing you have to prove it as 1 by root 2 log root 2 plus 1। fine, now first of all try to understand this expression written over here. if you again try to apply the property, that is, so you can call it as I or whatever, but let's do it, it will be like 0 to pi by 2, and it become cos square x, and in denominator I'll be having sin x plus cos x। now try to understand one more thing, if I call this is my equation number 1 and equation number 2, and both are actually equal to I, on my left hand side I'll be getting 2i, and my right hand side when my denominator is sin x plus cos x, that will remain sin x plus cos x only, and my numerator will become sin square x plus cos square x, that's 1। okay, so I'm again saving few time by just writing the redundant without writing the redundant steps। okay, now try to understand, I can call it as, if I just take next page, I can call it as I is equal to 1 by 2 integration 0 to pi by 2 1 over sin x plus cos x। now you know one thing very well, that sin x plus cos x, this type of expression in indefinite integration, how we do, we try to convert in terms of sin a plus b। so what I'll be doing is 1 by 2 0 to pi by 2 dx I have over here, sin x plus cos x I have, okay, so root 2 I have divided, so I have to multiply in the denominator also। now if you see this expression, this is your sine of pi by 4 plus x, Okay, or I can just take one more step to explain you. It is 1 by 2 0 to pi by 2. Okay, root 2 I can take outside dx over this I can write as like sin x, and this 1 by root I can write as cos pi by 4, and then cos x and sin pi by 4. Now you know very well it's looking like as what? It's looking like at a plus b expression. So 1 by 2 root 2 0 to pi by 2. Obviously the denominator will become what? It become cos of, sorry, sine of x plus pi by 4, and when it become like when you take 1 by sine, you know it's cosecant. So I can directly write it's become cosecant of x plus pi by 4. Now you know the integration of the cosecant, that is log of tan x by 2. So it will be nothing but 1 by 2 root 2 log of tan of x by 2 means like x by 2 plus pi by 8, because by 2 you have to do whatever there is inside the log. Okay, so you have done this, and obviously that should be a linear expression. That's a thing of different. We have deeply discussed in the chapter of indefinite integration. Fine, now let's come back to this, and when you will be solving what? Okay, so you got this, but the limit you haven't put. So limit was actually 0 to pi by 2. Okay, so I is equal to, when you now put 1 by 2 root 2, it will be log of, when you put pi by 2, it will be like pi by 4 plus pi by 8, so it become 3 pi by 8, or rather I said tan 3 pi by 8, not 3 pi by 8, tan 3 pi by 8, and other one will be pi by 8. Now again I know, or I can take like this will be log of tan of pi by 8. Now again I can apply the property of log a by b, that is equal to log a minus b. So I is equal to 1 by 2 root 2 log of tan of, just give me a second, log of tan of 3 pi by 8 divided by tan of pi by 8. Fine. Now you know one thing very well, that log 3 pi by 8 is your root 2 plus 1, and you sorry, tan 3 pi by 8 is your root 2 plus 1. So try to understand one thing. uh, Before that, I can write it separately, that if you see your denominator tan pi by 8, which is what? Which is, you can write as cot 3 pi by 8, cot 3 pi by 8, and cot 3 pi by 8 is basically 1 over tan 3 pi by 8. So it actually, when you replace your denominator, that is tan 3 pi by 8 by tan of, rather 1 over tan of 3 pi by 8, it becomes tan square 3 pi by 8 in numerator. So I'll be having my I as 0 to pi by 2. 1 by 2 root 2 was there, okay, fine, and log of tan of square, so that square comes outside 2, and it becomes tan of 3 pi by 8 only. Tan 3 pi by 8, no, root 2 plus 1, 2 cancel out. So I finally, okay, integration was not there because we have already solved up. Let me just erase this part. Okay, we are just putting the limits actually. So I got this. Now log of, so okay, 1 by root 2 will be having, and log tan 3 pi by 8 root 2 plus 1. You must know that 3 pi by 8 is actually equal to 67.5 degree, which is root 2 plus 1, and tan of 3 pi by 8 you also must know, that is equal to root 2 minus 1. So fine, this is what you have proved. So little bit of trigonometry knowledge also you must have to solve this question, indefinite integration. So this is quite a good question where we have applied many things to solve it. Okay, now let's come to the question number. Okay, so here you can read the see the pre-written solution also. So you can always refer this to get your answer and better understanding. Now let's come to this question. Okay, in this session we will be just discussing this. This question will I have already shown. You can try it and you can have it in the next session.